And we are recording. Welcome to the evening of Python coding. Again, each month we here show a different Python tool or library so people get to know it. The community typically helps showing those. Um, Today we have Illia Kozlov is going to show a relatively new tool, an AI tool called LlamaIndex, which is very important for some AI practices that are happening today, but I will let Ilya explain it instead of me. So Ilya, go ahead.
Okay, cool. Thank you, Jacob. All right. Hello, everyone. My name is Ilya. And I am going to talk about LlamaIndex today. Let me share my screen. Okay. So, okay. Can you guys see it? Okay. Can I get some? Is my screen visible? Okay. Yeah. All right. Okay.
You're good.
So,
Now
I'm
you're
good.
showing us, yeah, but
Okay.
now you're showing us the blank thing. Llama index
Huh?
it shows.
Yeah. I was gonna show the slides, so that's fine.
Okay.
Okay. So basically with the way AI is developing now, there's a lot of frameworks that have come out and different tools that help build software using large language models, including but not limited to. And one of them is LlamaIndex. So um, it's a pretty big frame. It's a Python-based framework. Some people call it a agentic framework or just AI framework. It has a lot of different use cases, a lot of libraries within it, and different purposes you could use it for. But I'm going to talk about one particular one today, which is retrieval augmented generation, or RAG for short. So first of all, what is RAG, right? What is retrieval augmented generation? This is a chart that basically shows kind of the concept of this process. Imagine you have a PDF document with some information. Let's say it's a legal contract, right? And then it has a lot of pages. It's long. It has a lot of information. Um, and you need to find some specific information in it to answer your question. Let's say it's part of your workflow as a lawyer. So usually what you would do, you would open that document, you would maybe do some control F, maybe some searching, some scrolling, reading, and until you actually find the answer to your question. Now, a better way to do this is to have a chat interface where you can just ask a question about your contract and have the system give you an answer about exactly what you were looking for, right? So this is the purpose of RAG. Um, so as you can see, uh, you start with some kind of knowledge base. It doesn't have to be one document. It could be a collection of documents. It could be a folder, or just basically any kind of data source. And then um, uh, what we need to do to make it work is we need to um, take a large language model, which is a neural network, or what we understand by AI in this case, and we need to make it understand our documents, or have context about our documents. So how do we do that, right? Well, there's a process called embedding, or vectorization, in other words, which is basically a process of taking your documents and converting them into a format that an LLM will understand, if I'm going to put it in simple terms. And as a result of the process, we're going to get a vector database, or this vector DB block right here. Once we have it, it can be stored on our It's just a file, just like any other database. Once we have it, we can actually start making queries to our LLM, which is just natural language questions. And then our questions or our queries, they're going to get turned into or vectorized, turned into vectors as well. And then they will be compared to the rest of this vector database. And whenever the algorithm finds a match or finds similar information in the database, that's the part that is going to return back. And that's what this top K chunks refers to. Basically, it's this is our relevant information from the database that we retrieved. And this is what the word retrieval is for in RAG. So, and then once this information is retrieved, it comes back into the LLM context, or like memory, and then the LLM is able to generate the final answer for us, taking into account this context that it has, which gives us this final response. So that's basically the pipeline, right? So let me try
before you go on, let me ask you a question so people understand why we need this RAG at all. Okay? Describe the world without RAG. What was people doing before? Like what?
Okay.
I go to talk to ChatGPT or Gemini or one of those LLMs, and I ask it a question. Without RAG, what was going on? What couldn't they do?
So what they could do is, if you ask them a question, they would answer based on the data that was fed into them by companies that were creating those them. So like just publicly available information or something that's public knowledge, right? If you have your, like my example with the legal contract, which is your contract, only you or your company, your organization knows what's inside of it. It might even be confidential, so it can only be available to you. But if you want ChatGPT, let's say, to know what's in your contract, that's why you need RAG, because the public tool like ChatGPT won't know that, so it will never give you accurate answers about that.
So it's kind of a way to actually allow you to have your have the capabilities of an AI like ChatGPT, where you ask questions, but at the same time not disclosing private information, correct?
Yes, in a way, yes. Basically, what it is it's a chat interface over your own data.
Okay.
That's what it is. And another reason it's important is, if you think about businesses, just companies, organizations, any type of business has data. Absolutely once it starts to grow, and every company, even within the same industry, they have their own specific data. It's always it's going to be unique most of the time, because they will have their own operations, their own philosophy of doing things. So all of that is going to belong to that company. So if you want to be able to query and chat with that knowledge or that data, that's where you need AI and something like RAG, and
now,
something like LlamaIndex.
Let's before we go on, I want to make sure that what we said here is absolutely understood and correct, because when you are using RAG system, let's say LlamaIndex, and you're using an AI like ChatGPT or Google or a local AI, doesn't matter. You do give, when you ask the questions, you do give the company who's operating the AI, first of all, your question, and then
Yes,
the other part is whatever your database gives out. Correct?
that's true. That is correct.
So,
Yes.
So it's not fully secret. It's only partially. You don't give the entire data, but you are giving it enough information what you are asking about currently, correct?
You are giving it whatever context is retrieved from the vector database. Yes, whatever similar chunks are retrieved. Yes, that's what you're giving. But only if you're using cloud models, meaning only if you're using OpenAI models, GPT models, or Gemini, or things like that. If you're working with local models, which we can talk about later, then you're going to be fully confidential.
Okay, we have a question. What is the advantage of RAG pipeline? Is RAG prepping the data for the LLM? It says
Okay,
in
let
the
me.
chat. I just
Yeah,
read
yeah,
it.
yeah, I see it. I'm just going to read it. What is the advantage of a RAG pipeline? Is RAG prepping the data for LLM? Yes, yes, for sure. Yes, you are correct. It is uh, it's a process to give the LLM more information so it can give better answers. The just so it can give tailored answers, if that makes sense. Curated.
But it's tailored to your question, correct?
Say it again.
The information is tailored to your question, the thing you asked the LLM. So
Well,
it's an
yes,
interactive.
but
Show back the diagram for a second.
yeah, here's the diagram.
So you have a query, and the
Query.
database, yeah. So it doesn't go directly to the query database. It goes to the LLM first. This is
Yes,
part of
so the query goes to the LLM, then the LLM, uh, regardless of the query, it's gonna do a round trip to the database. It's gonna do like a request, or it's called similarity search also. It's gonna do this trip to retrieve to compare the question to what it can find, and then retrieve similar chunks. And then when it comes back, uh, the LLM is gonna um, take it into account to generate the response. Um,
So the LLM is not only at the end, the LLM is also where the user query is going towards. It's the same
yes,
LLM, but there are two copies.
of
Okay,
course, of course. The LLM is located. Yeah, if you think about it, it's in between the user and the data. So you have user on one end, data on the other end, and LLM is in between.
okay. So
Yeah.
go on, please. We
Okay,
interrupted enough.
that's fine. So now I'm gonna move on to an actual script, an example script that I put together to actually like run and demonstrate how it works. So let me hop over to VS Code. All right. Um, so LlamaIndex, when it comes to RAG, LlamaIndex is really good and really convenient because they have this 5-line like starter script. Basically, you can set up a RAG pipeline in 5 lines of code. That's what they say. So this is basically what I'm going to be showing. I mean, there's a little more than 5 lines, but it's because I added some comments. Um, so I guess I'm going to go through the code quick, and then I'm going to run it. So, I mean, first things first, you need to install the library. So pip install LlamaIndex, or UV install LlamaIndex. And then we need to import some things, some abstractions from the framework. First thing is the vector store index. This is an abstraction that will handle our vector database, that little square from the diagram. Then simple directory reader. This is going to just read the PDF files or whatever files you have, and load them into memory. Then this is just I'm going to use some environment variables. later down here. Yeah, this is not that important. So now this line with the API key. Um, like I said, there's two ways you could go about your RAG. One is using cloud LLMs, the other is using local LLMs. This demo, this first script is using cloud LLMs. So what I did before, what I did prior to this is I went to OpenAI API website and I set up an API key with them. You would need a credit card for that and just an account with OpenAI. So you create your secret key and you put it in somewhere in a file, just somewhere where you can remember it. And this is how I loaded it. You could just copy paste it directly here. I just did this because I didn't want to show the key. Okay.
It's actually a general way of doing this. People don't like writing code where keys are inside. It's insecure because when you copy them,
Yes.
you copy the key, and everyone basically can use whatever your credit card is set up. But it's a bad idea. So what they do is the code itself is separated from the data. The data that he's using here now is actually sits in an environment variable in the operating system. He basically copied the key and now he's telling us to use it.
Exactly. Here on the left, I have this file called .env that stands for environment. This is where my actual key is located. So, and then I'm importing it in this way. Okay. Now, this first line, documents equals simple directory reader, and then so basically this line loads our document data into memory. In my case, I took just a PDF file. This is my resume file. It's right here in a separate folder called data. And you need to give it the name of the folder so it knows where to pull it from, and then just .load data. So now documents has basically the representation of that PDF, but in memory. The next step is to create the index. Yeah.
Okay. Go ahead. The documents now are just stored in memory as the documents, correct? It's like text.
Yes. Yeah, just like a document class. Let's imagine simple. Yeah, something like that. Now, the next step is if we follow this. So step one was basically to create this stack of documents. Now we're going to create this vector database, this yellow square. Index equals vector store index dot from documents. This function, so it takes our document collection that we just created, and then it vectorizes it, like I said earlier, or there's another word. It embeds the documents. You could say creates embeddings, and they are going to be stored in this index in this variable called index. Now, just also
what this index looks like.
Yes. So actually, I mean, I can do this, and when I run it, we'll see what it looks like. But essentially, the word vector here means the vector from math. So it's just it's a sequence of numbers. You could think of it as a list of numbers, and they're all floating point numbers. So just several decimals. That's one vector, and this database stores just a whole lot of these vectors or lists of numbers, but each of them actually means something from the text, from your document text. I know it's probably not very straightforward. We're converting text into numbers, but that's actually how similarity works. I mean, in the end. Okay. Then once we have our index, there's one more thing we need to create before we can ask questions, which is a query engine. This is it's just a LlamaIndex construct, something that they put in place. We say index dot as query engine. And what this does, I have a comment here. Basically, it takes the index and it couples it with a language model, with an LLM together into one thing, so that later this LLM is attached to this data source. That's the best, again, that's the best way I can explain it, because I mean, I haven't actually looked at the source code to like properly understand how it works. But that's the idea. We are creating an engine to be able to query it later, to be able to ask it questions. And then after that, we can finally get our response, ask the question. So we say query engine dot query, give it a string with a question. It doesn't even have to be a question. It can just be a prompt. And the response is going to have our generated response. Okay, so let me try to run it. And I'm going to actually change this question. Since this is it is going to be about my resume, I'm going to ask something like this. How many degrees does Illia have? Okay, let's start with that. I'm going to save it, and I'm going to run the code. Okay. Document loaded. Then we see index created, query engine created, and okay, and this is our response. It says Illia has 2 degrees. Well, this is correct according to the source. This is correct, and this is we were trying to see what this index is, right? And yeah, I mean, it doesn't actually show us those vectors. I think you need to do something else to actually show them, but I mean, it's an object, so it's just an object in memory, vector story index. Okay, let me try to ask something else, something more complicated, or something more specific. I don't know. What class? What?
Where is Illia from?
Where is Illia from? Okay, let's see if it can figure it out. Right. Okay, that is perfect. This is indeed my hometown.
Now notice, before people move on. If Illia did not give his CV, you would ask ChatGPT, where is Illia from? It will give you a totally different answer, because there are many Illias. He didn't know where, he didn't know what. Now he's directed to the ChatGPT is actually knows I'm querying this database before I'm giving the answer. And there's a question online: what is the advantage of doing this programmatically rather than directly loading the resume into ChatGPT and then ask the question? Okay, that's a good question.
What's the difference between just loading this into ChatGPT, right?
Yeah.
Well, basically, like that would be the same. Like you would get the same result, but this is like a toolkit that you have. This is a development toolkit. So obviously, I mean, if you're doing tasks as simple as look something up in a resume, you could use ChatGPT, and if it's a one-off task. But imagine if you are doing some iterative work. Imagine you have a document with, I don't know, 500 pages that you need to sift through, or you have a collection of documents, which each of which is big. LlamaIndex will it processes documents very efficiently, first of all, and since this is code, since this is just, I mean, this is not a black box, this is a white box. So you as a developer can build any kind of system. You can build any piece of software around this and integrate it into your own workflows, your own applications, and just make it comfortable, make it, make it however you want.
Let's make this answer a bit more complicated. Allow me to ask you, Ilya, play with me here.
Okay.
So what if I had the entire Library of Congress and I wanted to ask a question about?
A Library of Congress?
Yeah, it's big, no?
It is, yeah.
Can I plug it all in ChatGPT and upload the old documents?
Directly into the ChatGPT interface? I doubt that.
Okay, so there's an element of how much what size of a document you can give ChatGPT, correct?
Yes.
But you can store the entire Library of Congress today on a regular computer or a bunch of computers or database that you're accessible, and then ask LlamaIndex to pull the information from.
Yes, you can.
You cannot give the entire Library of Congress to ChatGPT, but you can store it locally and then ask questions about it with LlamaIndex, correct?
Exactly, yes. And that way, ChatGPT won't load the entire library into its own context, because that's actually impossible. Its context is not big enough. It would do the similarity search. It would do the RAG first, and then use the relevant context to answer your question.
Yeah, and the question is how much it will cost you. Now, I don't know exactly how billing mechanism, but today most LLMs online on the cloud, they have something called the context window. This means the size of the information you can pass into the LLM without it going haywire. Okay.
Yes, that's correct.
If you're using LlamaIndex, you don't have to use the entire context window while giving, but if you put the document inside, you might use a lot of the context window, which will cost you more. It also will take more time for the LLM to answer. And many, many other things, while the RAG operation is relatively simple. Also, very important, sometimes you don't want to give information outside your organization. If you're giving the entire database away, then that's it. You gave it to ChatGPT. But if you're asking some questions and answering only about some things that you related to the answer, you might live with it nicely. Because you're not giving the entire, it's not like you're asking Google and something and Google remembers every question you ask. So,
right.
Now it's a more complete answer.
Okay. Yeah. I mean, I agree with Jacob on this, and even beyond this, there's a lot more advantages. Like moving forward, it gives you flexibility, and this is just a 5-line example that we talk about here. It has all kinds of other just improvements, extensions for this RAG. Just you can insert some steps in between. You can, expand. You can maybe you want to have some custom parsing or processing for the data before it even gets vectorized, or maybe you want to change. You can even change the settings. I think you can tweak the settings of how like how it gets chunked, how big the chunks are. So like you have a lot of control over it if you really want to get like deep. Okay, so.
Well, before we go on, okay, Google is raising his hand. I assume he wants to ask a question.
Yeah, I just I'm a little bit confused about division of responsibility between the LLM and LlamaIndex. So like is the creating the embeddings for the document and also embedding your query for the vector search, is that all done locally through the library? And then the retrieved results along with your original query are then passed on to the LLM. Is that how it's working?
Okay, if I heard you correctly, because there was some extra noise. Yes, your data, your documents are stored locally, and the RAG round trip, all of that is running locally wherever you run it. And ChatGPT is only receiving some context that's it from your local database. So let me go back to the code here. Basically, this line and these three lines, they are running locally on your machine. And then this last line, when you do a query, it makes a request, an HTTP request to the OpenAI servers to invoke the LLM and to make it generate you the response. So yeah, I believe that's how.
Okay, I think the internet tutor also raises his hand, although it's a tutor. I don't know whether it's a person or not. So if you
Yes,
have a question,
yes, I have a question. What about file structure? When you put all the files, right? I do not want to flatten it. So would it work? We'll search the whole data, the whole file structure for all of my files. Example, when I have source code.
So you're talking about if you have all of your source code in one folder, and if you make that folder your source folder, then it should work. But I don't think source code, like code files, are supported as a data source in LlamaIndex.
So it's mainly then for a documentation.
Yeah, so it's going to be PDF, it's going to be Word documents. I believe Excel, they support Excel now.
LlamaIndex can process text and code this text. So
Well, at the end of the day, yes. It's just I'm sure it has some kind of configuration for that.
oh yeah, it can
I'm just
process.
personally not aware of, yeah. But if you search for it in the documentation, let me show you something else real quick. This is LlamaIndex documentation, right? Am I sharing? I'm sharing.
Yeah.
Yes, you.
They have a cool feature here on their documentation website, which this is literally what we just talked about. This is a RAG, this is a chat interface over the documentation. So if you want to know if it supports something, you just ask this, and the AI is going to tell you. So, okay, let's.
Can you do with text documents?
Does LlamaIndex support source code files as data source for RAG? Let's see.
I'm pretty sure it supports text.
Yep, so it's saying that yes, it supports source code. You can use Simple Directory Reader, which we used, to load code files and apply code-specific splitters, like Code Splitter, for better chunking and indexing quality. This enables blah blah. Yeah, so according to
And what about file structure? Okay, and what about file structure?
File structure, so you said you wanted to flatten it, or?
No, I am trying to avoid flattening it.
Trying to avoid. Okay, so I got you. If you have a tree, if you have a file tree.
Correct.
That's a good question. Okay. This is interesting. Okay. Okay.
So that's an option.
Yeah, it's an option. Let me see if that's actually recursive equals true. Uh,
Here. Do the
yep. That's correct. Yeah, recursive is one of the keyword arguments that you can use. So that's
Thank
actually
you. Thank
yeah.
you very much.
That's a very good question, by the way. I didn't know that personally, but that's super cool.
Okay,
All
Ilya,
right. Yep.
why don't we go on? If there'll be more questions.
Yeah,
you
we
ask.
can look. So basically, we could go on if we have time.
We have
But I'm
time.
done. We have time. Okay. So I'm done with the cloud with the demoing the cloud example. Now I'm gonna move on to a local example right here. Now, so this is gonna be the same script, but there's a few differences, and it's slightly more complicated. Basically, what I wanted to see is, can I do the same? Can I set up the same pipeline but avoid using ChatGPT, OpenAI's model API? Because first of all, I'm paying for it, and it's second of all, I'm giving my own data to it. So what if you want to use you want to run local open source LLMs like Quen or Llama or any other? What if you have hardware for that, and you want to incorporate them into this pipeline? So this is what it's going to look like. Um, Now, I will say LlamaIndex doesn't support this very well out of the box. So I had to write some extra. I had to write some extra integrations on my own. That's why. I mean, but I'm still going to show it anyway. We still have vector store index. We still have simple vector reader, and we're going to need this settings abstraction. And then these two things are the classes that I wrote, because we're going to use something called Llama CPP to execute, to run LLMs locally. And we're going to use Docker also for the same purpose. But
Ilya,
yeah.
LlamaIndex can support local LLMs. There are multiple ways to do this. What you're showing is one.
Right. What I'm showing you.
I did it with other types of code. So this is like, first of all, let's explain what you're showing here is one way to do it with local LLMs. Go on.
Yes, this is one, definitely. Okay, so first thing I'm doing is, okay, there's something else we need to understand. Back to here. When we were at the vectorization stage, I mentioned there's this process called embedding, or you can say that you embedded information. So that's actually done by another neural network, by another model that's called embedding model. It's separate from your LLM. It's a totally separate thing, but it's this black box that converts your text into vectors, your text into numbers. So if we want to do this locally, we need to use our own embedding model. And I have one here somewhere. Well, I have one downloaded onto my computer. It's called Nomic Embed Text. I got it off of Hugging Face. I can show Hugging Face later if people are interested.
People don't know, Hugging Face is like GitHub for models, for AI models. You can get
yes.
models there.
Okay. Now, so I just saved this path into a variable so I can use it later. And then I said settings.embed model. The settings, this is coming from LlamaIndex. So what we're doing, we're just setting a different embedding model that comes from us instead of what LlamaIndex uses under the hood. And I'm using this class. This is again, this is an integration that I wrote, and it needs a model path. So it's going to take this path, and this is not that important. From here on out, our vectorization is going to be done by nomic embed tech after this line. Now, next line, we also want to use our own large language model, so the actual chat model that we're going to talk to. And for that, I used, again, this is not the only way, but this is a way to do it. I used Docker because Docker, they have added a just as a separate feature, they've added as a possibility for you to download models here and then run them just directly on your computer. So this is what I have downloaded. I have, for example, Qwen 3, Gemma 3N, Qwen 2.5, Llama. All these different, and they're small. They are all, I think, up to 8 billion parameters, because that's the most I can run on my laptop.
How big is your GPU?
I don't have. I mean, I'm running this on a MacBook, so.
Okay.
Yeah, and we'll actually see, and we'll compare the speed and like the performance.
And how old is your laptop? Your
MacBook? I think it's a 2023 MacBook, so it's like a couple years old. I have an M2 Apple Silicon. Right. Okay. So using this Docker abstraction, I'm gonna initialize the LLM. I'm gonna use Gemma 3N. So this name is coming from right here, AI/Gemma 3N. And this will just initialize it into the memory again. And then this is already familiar. This is the same thing we did in the cloud.py. We're going to create the document store. We're going to create the index. And the difference here is when we're creating the query engine, we need to pass our LLM as an argument into the query engine. Again, because by default, it would use OpenAI's LLM, but we want it to use Gemma 3N. So we're going to say LLM equals our local LLM. Okay, and I mean, query engine.query, same thing. Okay, let's try this. Let's see what it does. Think of a good question to ask. Probably what languages? I'm going to ask about languages that I speak. Okay. Document loaded, index created, query engine created, and it's taking a little bit of time. So you can already see that the latency is bigger on this one, but there's a response: Ukrainian, Russian native, English fluent, German beginner, Spanish beginner. Yep, that is correct. It just took this line directly from here. So And the output is slightly different also because this there's all these GGML metal, all this output. This is from coming basically from running Nomic embed text and from running this Gemma 3N on MacBook because it's just the output that comes from these LLM backends. Okay, so I think that's
There's someone who needs confirmation. So there's a question in the chat. Since you're using local FM, you are not connecting to ChatGPT, correct?
yes, correct. Correct, absolutely correct. Sure. This local.py it's closed out on my MacBook, and everything is happening on my MacBook. Yes. So again, I have a 2023 M2 MacBook Pro with, I believe, 24 gigabytes of RAM. And so this question, I don't know, it took a few seconds, but it definitely took longer than the response from the cloud alone. But it's still not bad. Still not bad.
Yes, Ilya, is there a way to do some preloading in order to avoid the latency?
Preloading.
What latency are you talking about?
Well, every time you ask a question, if you run the Python program, it will do all of that part, right? Of having to connect and having to read and all of that. Can this specific part of the program be done and then just get to the part in which you can just ask the questions? So I don't know if I am using terminology, but there should be some way to actually do that, I'm guessing.
Once you have the vector index, then that's it. The questions are only processed by the LLM.
So that's actually, you could do that, but you would need to design your application in a way that it only creates the index once, and then you query that index for every question that's asked. It's querying the same index that's already in memory. Yes. If you want to avoid latency, yeah, but you would have, I mean, on the other hand, you would have, if your index is large, you would always have it in memory, so that could take up a lot of your RAM if you have it loaded. So there's trade-offs there. You would need to test and see. Maybe I mean, there's different things you could do. You could load it all at first, and then have some kind of timeout. If the next question hasn't been asked in X amount of seconds, minutes, then you unload. You remove it. Something like that. I'm just kind of brainstorming.
Yeah. Thank you. Yep.
Yeah. But again,
actually,
sorry. Go.
yeah, actually, in real time, like you mentioned, we always index all the document, store it into a data store, something similar to a relational data store, the vector databases, and then we run the similarity search against that database, get the relevant chunks, and then pass those to the LLMs. So in real time, when you ask a question, only we will be directly going and running a similarity search against all of the indexes we created.
Mahesh, you all touching on a question that's like, Ilya, can you open up, show LlamaIndex vector stores, show it what it supports?
Right.
The documentation?
Yeah, the documentation, just find that there's the vector stores, all the vector stores, you can actually look at them. Here, list all the vector stores that you could use.
Yeah,
or
on the left-hand side menu, if you just scroll down, you see all the vector stores it supports.
Yes, somewhere here. Yeah, right here. Oh, yeah, there's
So
That's basically your.
but like Redis is only one. It has lots and lots of ways to store data, starting from databases, full on, all sorts of ways. Directory of structures, different types of ways to read the directories. Look, guys, this is big. It's not the nice thing about LlamaIndex. It's like the interface changes very little, and it has a lot of things that it can support. Many things, and they keep on changing, by the way.
Yes, it's essentially is an aggregator of all these. I mean, um, for every pipeline or like workflow that it has, it provides you not one, not two, but tens of different options of like database vendor or you know just options to replace the same thing.
Yeah.
Yeah.
Some of them are faster, some of them are more persistent, some of them are you choose your own, and later you can test multiple until you find something that's good for you. And not
Yep,
all
that's
of them
true.
are good for all use cases.
Exactly. It has integrations. Also, it has so many integrations. If we're talking about local LLMs, it has an integration with Ollama, right? Ollama, the tool to run local models.
Yeah,
It has an
you can
integration with Llama.
you don't even need Olamo. There's a way to actually load an LLM from Hugging Face locally. There are all those.
Yeah,
There are
yeah.
plenty of functions.
Llama CPP, Ollama, VLLM. Yeah, it's just pretty much everything you could.
And it integrates with other tools as well.
Yeah.
Like what's the name? The one that passes data. It actually used it before. When you ask it, it gave you what's the name of that?
The one that.
You ask a question like before, like in the window. In the window, you ask a question, and it actually
Oh.
told me a function like how to split the data. So it
Oh,
comes.
yeah. Yes, that's like text splitters and code splitters.
Yeah, and they can come in from different libraries as well.
Yep.
It's what's the name of the library it's used on regular?
Yeah, so if you want to get deeper into and customize the pipeline, then you can.
Yeah. So it's a pretty heavy tool. What we're showing you is only a very small tip of the iceberg.
True. Okay. So I think we've looked at this. I think there's nothing more to demo. We can, if there's any more questions, we can.
Yeah, someone is asking for your Docker with all the models. Do you run your Docker locally?
Yeah.
I think we lost Ilya somehow.
He got mad at us.
No. Something happened. Here he is.
I apologize. That was me. I'm back. Okay. Yes, I do run Docker locally. Yes. And I just thank you. I have Docker desktop installed. I pull models in there, like you download them from there, just like in Llama. You just look up the model and download. It downloads it into your disk, and then you can chat with it in the Docker interface if you want to, or you can use its API to do inference, to make requests to it. I'm gonna.
Any other questions for Ilya?
This is a Docker desktop and models section.
Yeah, Craig, ask your question.
What is sorry? What is RAG workflow compared with LlamaIndex? Is LlamaIndex a type of RAG workflow?
So LlamaIndex is a framework, is a Python framework, and RAG is like a piece of functionality or like a pipeline that you can build using LlamaIndex.
LlamaIndex implements RAG and some other things as well.
It implements RAG, yeah. You can say.
Gotcha. Okay, thanks.
Okay, there's also something called CAG. This is what you called before. You were asking questions about why don't I put the document directly in ChatGPT? This is sometimes called CAG, which is
Context document generation.
Yeah, sometimes it's context, sometimes they call it with cache, but so RAG has some advantages. CAG is very simple.
Yeah.
Any other questions by anyone? Come on.
I had a question.
Sure.
Yeah, someone wants you to share your LinkedIn. You'll share it
Just
later.
to go all the way back, there's something towards something in the start of this. I'm sure you had to program it just right, so that way, if it were to determine where your hometown, it'd have to be very precise to make sure it doesn't mix up your hometown with wherever your alma mater was located. You know, where you went to school. I mean, did you have to do anything really specific to make sure it doesn't mix up where you were born with where your school your university was located, or does it automatically know how to do that?
So thank you for the question, Craig. That's a good question. I'm gonna pull up the resume once again.
So
yeah, I get what you're asking. So hold on. There's only one mention of this city in the document, and hold on. So I'm kind of, I don't know the answer actually. I'm trying to
Well, I'll help you.
think through.
I'll help you. The answer, Craig, is that LLMs are like glorified parrots. In this case, what happens is when the embeddings, when you put in the data in the vector database, when you ask a question, it looks for the things that are most fitting what it thinks it's fitting in what it sees. So it's basically the LLM is fed back this thing and tries to figure it out on its own.
Yeah.
The LLMs today are very sophisticated. A lot of the time, those questions are pretty easy for them to answer. It's not 100%. Okay.
Yeah. So
but basically, the fact that you're asking questions about location, they figured out this is location, then they will spit this out. It's not always, but in this case, it's not typical. They typically won't get it wrong. Okay. They will get wrong in case you have many like cities all over and for all sorts of things, and this is where I traveled, and this is where I was in Vienna, and this is where my vacation was, and there are all sorts of this. Then it might start looking for the needle in the haystack, and they may get it wrong. In this situation, it's pretty straightforward. There's only one or two locations on the document. It's pretty easy for the system to figure out. I need a location. That's a location. And since in the vector space locations are somewhere else from anything else, then yeah, this is.
But then also, that was not the only location in the resume, right? There were some odd, like, I think it looked.
Can I say something real quick? I'm sorry, I might have gotten the facts mixed up because you mentioned your hometown was in Dnipro, and maybe I kind of missed it because maybe I kind of mistakenly assumed like it said on your resume that one of the schools you went to was in Dnipro and your hometown is also in Dnipro. I thought it said on your resume, but it didn't. So I might have gotten my facts mixed up when I asked.
So
if that's the case, I apologize.
So no, you're good.
And also, I just want to say, yes, Jacob, I know that AI is kind of like a parrot. It just repeats stuff back at you, and it really gets things wrong. I have my own share of stories of AI getting basic facts hilariously wrong, so I know what that's like.
In this situation, this was quite on because it really wasn't that hard.
Maybe something else it did is that it looked at the dates of when I finished my first degree and when I finished my second degree, and if the date of the first one was earlier, then it looked at the location and it thought, well, okay, if he had got his first degree then and there, that maybe there's a high chance that that's his hometown. But
it depends on how sophisticated the reasoning models will do this. The ChatGPT 3.5, I'm not sure it's on.
Yeah, that's true as well. So truly, we don't know how it made that decision, but the resume didn't actually specify where I was born. So
And it also depends on the chunking that was made. So it's like he
yeah,
may get in it may be just chance because GPT got like 3 things. One of them he picked one that seemed reasonable. Who
yeah,
knows?
maybe.
You never know at this point what it is. It's a black box, but those black boxes are pretty good right now.
Yeah, also
Any other questions?
in other perspective, it is interesting to think that
Thank
in
you.
this particular scenario, LLM have hallucinated, right? Actually, the information is not really provided to it through the RAG, but
Yeah,
it made it up. So basically, it hallucinated,
it made a successful hallucination. That even makes sense.
right?
Yeah.
So, guys, people say hallucinations too much in this point. Hallucinations, when you see them bad, it's like a good, really drunk person. This wasn't a hallucination. It knew the answer because it was an easy question.
Mm.
Okay.
Well, that's
Any other
also true.
questions?
Yes, I have one more. What about these models? Generally, you can pre-configure them with directives, markdown documents. Is there a way to feed them those documents maybe in order to tell them, for example, ignore certain type of documents or ignore certain paragraph, assuming that, for example, your code base or your document base have certain patterns, but there are certain directories or certain documents or certain paragraph or certain type of information that you do not want to be part of the information to actually load those directories before running the program, so it will learn how to ignore them.
Okay. I see what you're asking. So basically, you want to add a system prompt or a set of instructions to the LM before running it. Yes, that is possible. You would need to basically you would need to create an agent using LlamaIndex, and then it will support many different things, including system prompts. You can LlamaIndex has a lot of agent abstractions. I think there's React agent, there's function agent, there's a few more, which you basically you take an LLM, you pass it into function, then it creates an agent instance, and then that instance will have parameters, one of which would be system prompt. So you would define it and like add it or attach it to that agent, and then later, instead of doing query engine dot query, you would be doing like agent dot query or agent dot ask or something like that, depending how you build it. So that would be a use case, an agent use case, I think.
But the Python program in itself does not have a way to read the markdown document with those directives.
To read the markdown, so you want to have
Yes,
you
a
want,
markdown document where I
okay,
have directives, and then when I run the Python program, it will read that markdown menu and have the LLM to follow
I
those.
see. I see. That is a good question. Again, it may. I'm pretty sure it's possible. Through LlamaIndex, I don't know off the top of my head how to implement it right now. We can,
You can implement a database and then decide what to do with the database. It doesn't matter.
Well,
Yeah.
you would need to find a way to say that here's a markdown file. Please use that as your as your instructions. Like you'll need to do
It's a
that.
Python program. You write the Python program to parse the markdown, do whatever with it, and that's it. And then you start doing everything. It's all possible.
Well, I
You write
mean,
the program.
yes, but like eventually, how do you load it into the LLM?
Correct.
brain. Like,
You
yeah,
decide
that
what
makes
prompt
sense.
goes in the, you decide what prompt goes into the LLM.
Well, and that's why I was talking about system prompts. So system prompt is just what gets appended to every prompt as a prefix, like as a one large prefix.
Or you can just write your own prompt, whatever you want. No big deal.
Yeah, I mean,
Here,
it's the same.
Show your code once more.
Uh-huh. Okay. Hold on.
So basically, you're saying that it would be the equivalent to the custom instructions or those.
You're doing it more complicated. Let's show you exactly how it's done. Go straight down to the last line.
To the last line, yeah.
Yeah, here. What languages does Illia speak? Here you put in a string, correct?
Yes.
You can get the string from an MD file, and that's it.
String
what
from
I
an
want.
MD file.
He wants to read it, to have the prompt in an MD file, so sure.
Right. So you would like say something, you send something like here, like response. No, actually, no.
File.read, then that's it.
Yeah, something like this.
It's file.read. You have to
Plus,
define file was.
and then this is like the second part is our actual question, and the first part is whatever. Yeah, this is a markdown file that should be like
and instead of
loaded.
the string, put in prompt, and that's it.
And then this prompt will go in here instead of the string. Yeah, just like you.
It's
Yeah,
easy to do. It's easy to do.
it makes perfect sense. So the custom instructions will always be prepended.
Yes, just like I said, as a prefix, as one long prefix.
Yes. Thank you.
Yep.
Okay. Any other questions anyone has? Questions going once?
I have a question about, I guess, the embeddings. So I'm just kind of curious, like, let's say you have a speech that somebody wrote with a lot of rhetorical flourishes and like redundant information. Is there a way that you can embed it and sort of like deduplicate it, so to speak, so that you're not sending redundant tokens in, like with your prompt, if you're trying to get information out of it?
There was a lot of noise around. I couldn't actually
having problems
hear
with
the. So the microphone's quality was just not.
Yeah, sometimes.
So if you
can you
were
write
talking
the
about
down in the
write the question
in the
down
chat?
first. You were talking about deduplication or something, like sending redundant information to the LLM.
I couldn't understand. You can try, perhaps with CC sometimes, then closed caption sometimes we can understand.
Can you use embedding? Can you use embeddings to remove redundant information from the document? You would use something else to do that, not embeddings.
Yeah, explain again what embeddings are.
Embeddings are sequences of numbers that are converted from text. So just like lists of numbers, you can even imagine it as one big matrix. It's just that's your embeddings. It takes
it takes the data, it chunks it into small chunks, and then it converts the chunks. Each chunk gets a vector of a certain size. It's always like fixed, like 2048 or something like that.
248, yes.
And now you have vectors that represent this chunk of text. It can be a figure, it can be an image, it can be voice, it doesn't matter, but those embeddings represent. And this is the way LlamaIndex looks for things that are similar.
Yeah.
Just by comparing those vectors. Think about it, those vectors are like places on the map. Okay, and then it looks all the things that are close on the map to whatever you're asking. Okay, so it's not embeddings to actually reduce your data. You can remove redundant data before you do embeddings, and that's it.
Well, I mean, I guess.
Or you can just embed everything, and then when you ask your questions, the things that are redundant will be removed because it will return only things that are really similar. So you don't have to worry about it that much.
Right, because like only the similar chunks will be retrieved. So I don't think retrieved information would have redundancy, like duplication in it, because it shouldn't. But that depends on the.
Even if it is duplicated, you don't care much.
Yeah,
It's,
I think
it's
we can trust. I think we can trust LlamaIndex on that because their implementation of.
No, you don't care even if it's duplicated. It doesn't matter because the answer will be the same. It's a duplicate. That's it.
Well, I mean, the concern was the person was asking if there's duplication, then there's more context that's sent to the LM, so like it's going to take up more of its window. You know, that's the concern.
That's the last of your worries. Believe me. When you
guess.
get to the worries that this is the thing that bothers you, then this means you've done a lot.
Then your system is probably already very
Machines
good.
are not like humans. People think always they give because those glorified parrots talk to us in like LLMs. They talk to us back and forth. People assign them with like things that humans do this way. No, those are machines. They do things differently. You don't care. Okay. Any other questions? Questions going once? Question going twice? Questions going 3 times. Okay, no more questions. If there'll be more questions, we'll answer it. First of all, I want everyone to make some noise, clap, do some emojis so people will be happy. And Ilya, thank you very much for a very nice presentation. I think you covered RAG very nicely.
Thank you.
I am going to stop the recording, but don't go away. We haven't finished. So again, thank you, Ilya.